why we have to use most of the time we use mercury as a gauge fluid in order to identify the pressure of the atmosphere, because here you can see there is the open surface, and we have discussed that the vapor pressure is only the function of pressure. If we use the water in place of mercury, definitely water vapor pressure is much higher as compared to the mercury approximately has a vapor pressure almost equals to 0. So mercury will give you a more accurate value, because if the pressure increases in that part, what happened, the vapor pressure exert force on liquid interface and their direction is downward. Okay, so definitely they reduces the height, and the presence of the vapors reduces the height of the column, and show that definitely if you calculate the atmospheric pressure considering that height of the column, there is an error of your calculated value. So even though if you want to calculate the atmospheric pressure using alcohol or water even as a gauge fluid, so what you need to have to do is you have to add another factor in this equation, and you have to subtract the vapor pressure of the gauge fluid at that particular point, and you have to subtract all this factor from the vapor pressure, so you can easily get the exact value. But mercury, as we know, that has the vapor pressure approximately 0, so that's why it is used in as gauge fluid so often. Then we have a numerical, in which what we have to do is a news broadcaster reported the barometric pressure is 772 mm of mercury. Calculate the atmospheric pressure, and the specific gravity of mercury is given to you. Okay, from here, this is the data they have given us in the numerical. This is the height of the column, 772 mm, which I just converted in meters, which is equals to 7.772 meters. Okay, the specific gravity of the mercury is 13.54. So I just need to use this formula in order to determine what is the atmospheric pressure. The atmospheric pressure is nothing, just equals to the specific gravity of the mercury multiplied by the specific weight of water. This complete factor is actually equals to the specific weight of the mercury and multiplied by height of the column. So simply what we do is 13.54 multiplied by 9810 multiplied by 0.772 2. So and just need to calculate it. 13.54 multiplied by 9810 multiplied by 0.772 with come up with a answer which is equals to 102,542.75 Pascal. Okay, and this is the atmospheric pressure at that particular part of the system, and we have calculated absolute because it is related to the vacuum. So we come up with this solution which is equals to 102.5 kilopascal. The next is manometer. Okay, there are types of manometer normally: U-tube manometer, inclined tube manometer, and two liquid type manometer. U-tube manometer, I think we have covered in thermodynamics as well, so it's not a very complicated thing. Discuss U-tube manometer. Here you can see there are figures. In of the figure, it's one end, tube one end is open to the atmosphere, and on the other hand part is connected with the process. Okay, so when you are calculating the pressure with reference to the atmosphere, definitely it will provide you the value of gauge pressure. So whatever you are measuring the process pressure value in this type of manometer will provide you in gauge form, okay, not in the absolute form. On the other hand, there is a second type manometer, U-tube manometer, in which one end is connected with one part of the process, and on the other hand the second part is also connected with the second part of the process. In that certain course of the case happen, the manometer will give you the differential pressure reading. I mean, what is the difference between one part of the process to another part of the process? So it will give you pressure difference or differential pressure reading in that manner. So a U-tube manometer can be used in order to calculate the value. So what the reason for particular purpose? It's one end open to the atmosphere. If you want to calculate differential value of the differential pressure value, you can the both end with the process part. So it will give you what's the difference between that particular two part of the process. Okay, so that's it. And now we move forward to know that how we have to form a mathematical expression in order to determine the pressure using manometer. Let's suppose we have this type of tube manometer in which there is a point A and the second part is point B, and U-tube is connected with point A from one part and connected with point B from other part. Let's suppose this is fluid 1, okay, and this is fluid 2, and this is the fluid which we use in the gauge, which normally we called as the gauge fluid. Okay, so what happened? Let's suppose the specific weight value of A we are representing in the form of gamma A, okay, and the specific weight of the gauge fluid we are representing its value with the variable gamma 2, and the last one, the fluid which is at the point B, we are representing its specific weight with the variable gamma 3. So we move from one part to another part in such a manner that, let's suppose I am starting from PA and moving in that part to B part. So what value I need to determine? Let's suppose we have divide this manometer into cross section, okay, divide in the half, okay, of center in this part, and the pressure at point A we are saying that which is equals to A. So we start from PA, we add distance which is covered by the fluid A, okay, height A, okay. So this pressure will be equals to the specific weight of fluid 1 with the height 1. There is no need to include this height because the fluid present in this height is equals to the present in this height. So we cancel out these both factors here. Now the main difference come in response of PA and this height, this gauge fluid moves in that direction, in upward direction. So this is something which is happened due to the response of the pressure point A. So we subtract a specific weight of gauge fluid multiplied by the height covered by the gauge fluid, okay, and subtract as well what is the specific weight of the fluid at point B and the height covered by that part of the manometer S3 minus PB or equal to PB. It's a 2. This is the way we generate the U manometer mathematical expression. So if we know the pressure at point A, we can easily determine the pressure at point B, and we just need to know the heights of different parts. On the other hand, we just need to know what is the specific weight values of different fluid we are using. Okay, it's simple. Then we have a numerical in order to understand what is actually the U-tube manometer and how can we calculate the pressure using manometer. So in this numerical, what we have to do is this U-tube is connected with one with the container or with tank, with closed tank, okay, in which the water is filled partially and there is a space available for other hand. The other part is connected with the air which has a pressure of 16 A, absolute pressure it is, and at the upper part the valve is closed. So if you start to calculate here the pressures, definitely PA, if I am saying that this point has point A and pressure A, if you are getting the pressure with reference of absolute, so all that. What we have in mind is we have to determine the reading of the pressure gauge, and the pressure gauge is present here, at which the water is filled up to 2 feet, and when there is air pressure. So what we need to determine here, this manometer, and then we will move forward to determine is the pressure reading at pressure. So for I use the whiteboard to demonstrate this, okay. As you can see here in this figure, I notify this height as H1 and this height as H2, and what we know is we know what's the pressure at point here. Let's say this is point 1. We need to determine the pressure present here at point 2. So for that we generate equation. Similarly, what we have learned that how to make the mathematical expression of YouTube manometer. So I start here from here and move from this part to that part. So firstly I will include the pressure at point 2, okay, and definitely you can see in the response of this pressure, this height is covered by the gauge fluid, okay. So I subtract the specific weight of the gauge fluid multiply by, this is H1, and what's the pressure at point P1, will also subtract equals to 0. This is the basic equation we use in order to determine what's the pressure at point 2. So the point 2, the gauge the specific weight is 14137.9 multiplied by height 1. H1 is actually equals to 1.2192 minus P1, and we know what's P1 is. P1 is nothing, just equals to 110,285.7 equals to 0. Just resolve this equation. We can easily understand what's the value of P2. Minus 137.9 multiplied by 1.2192 minus 110,285 is equals to 0, and we come up with the value of 127 P2 521.93. Again, this value is in absolute value. This is Pascal and absolute. So we turn this in a gauge value. So for that we just need to subtract this complete value with 101,325, the atmospheric pressure. So it will be equals to around 26,196.93 Pascal, and with subscript of G. So this is the pressure of the air present here. After that, if we know the pressure at the upper part, so pressure at point 3 will be equals to the pressure of air plus the pressure developed by the liquid head or water head in that particular height, which we notify as S2. So we just write P2 plus the specific weight of water multiply by the height H2, which I have covered in meters, 0.6096. Or first you just need to write in the form of variable H2. So P2 is in the form of gauge. We have determined 26,196.93 plus the specific weight of water 9810 multiplied by height 0.6096. So it will be equals to 26196.93 plus 9810 multiplied by 0.6096. It will be equals to 32177.1 Pascal, and it is in gauge form. So which is the pressure read by the gauge. So if you convert this value in PSI, you will get similar answer of 4.67 PSI. I actually used to solve all numerical in SI system because I am so much comfortable in that unit system. So whether if you are you want to solve it in FPS system or bit system, it's up to you. But the matter is that your answer should come correct with respective unit. Okay, it's not like that you just solve that. So you have to consider all the standards of the units. Okay. So then move forward for another numerical. Here this is U2 manometer, and it is installed in such a manner to calculate the differential value between the point A and point B. So at point A, oil is present. Okay, mercury is used as a gauge fluid, and at point B, the whole fluid is water. Okay, so again, I will use whiteboard in order to demonstrate you. And firstly, I convert these units in SI system. So I have just converted all these values in SI system. Okay, and convert the specific weights as well with respective SI system, Newton per cubic meter. The figure is in front of you, so you can see that from point A, this distance is divided into part, that is 4 inch and 3 inch. So I represent 4 inch with the variable h1, and this 3 inch with h2, and this complete 12 inch with height h3. Okay, then I will try to form the mathematical expression for this U2 manometer, and I start from this point and move towards this part to point B part. Okay, so the equation will becomes in such a manner that first I am starting from PA. Okay, then there is a height h1 and h2, and both is covered by the fluid oil. So I multiply the specific weight of oil, okay, and add height h1 plus h2, because the combination of this height, both these things are covered by the oil. Then I have to add the specific weight of mercury, and the only height h3 which is covered by the mercury, so we just include that height. Now on the other part, in response of all these heights and pressure, the water has a height of 12 inch and 3 inch. Okay, so I will subtract the specific weight of water and multiply with both height h3 and h2, the 3-inch height. Because both height is covered by the water fluid. Then I have to subtract the pressure at point B and equate it equals to 0. Now I just put all the values because I need to determine PA minus PB. PA minus PB will be equals to, or I just put the values here in this expression, plus the specific weight of oil 8961.06 multiplied by H1 is 0.1016 plus H2 0.0762 and subtracted with add the specific weight of mercury 133,158.2 multiplied by height H3, which is equals to 0.3048, and subtract with the specific weight of water 9810 multiplied by both height H3 and H2. H3 is 0.3